measurements made in 1910 indicate that the common flea is an impressive jumper given its size. Assume that a flea's initial speed is 2.2 meters per second and that it leaps at an angle of 21 degrees with respect to the horizontal. If the jump lasts 0.16 seconds, what is the magnitude of the flea's horizontal displacement and how high does the flea jump?
So time is 0.2. What else did I give it to you? They gave you, that's my flea.
The time is 0.16 seconds.
Okay, let's erase 0.16.
And then the initial speed is 2.2 meters per second.
2.2 meters per second. What else?
At an angle of 21 degrees.
At an angle of 21 degrees.
And it's asking for horizontal displacement and the change of y. So change of x and change of y.
Okay, so let's write down our given again. Let's start with x. So x initial, I'm going to call this where the flea is as 0. X final, that's what we're interested at, right? We don't know. That's the question. Velocity initial, I'm going to break this component down. Where do I? This vector was 2.2 meters per second. I'm going to, with 21 degrees, so I'm going to break that down into my x component. This is adjacent, so it's going to be 2.2 cosine of 21 degrees, right? So my v initial is going to be 2.2 cosine. Oops, that looks very weird. But cosine of 21 degrees. And then v final, I don't know. Actually, it is the same, but we don't know. A is going to be 0, right? And t, they gave it to us, which is going to be 0.16. So let's see how many components we have again. We have 1, 2, 3. If we have 3 components, then we are able to find a 4th one, right? So let's figure out, it's the same formula. We've been using this formula again and again. It's, I can't write. V initial times t plus 1/2 at squared. V initial, we're looking for x displacement in terms of x. V initial was 2.2 cosine of 21 time they gave it to us, which is 0.16. And then my second part, because a is 0, this whole thing is going to be 0, right? Anything multiplied by 0 is going to give you 0. Can somebody plug in this into their calculator and see what you get?
It's 0.33 meters.
0.33. Okay, good. All right. Now let's go to the y component here. Okay, so I'm going to use a y component. Y initial is going to, oh, that looks like x, but y initial is, let me erase that. Okay. Y initial is going to be 0, right? Because that's where my reference point is. Y final, I'm going to call it something different because y final is here, right? That's my y final, but that's not where I want. It's related to Daniela's question. My final is right here. It's at the top, which is like y midpoint, okay? They're interested at my, not my y final, they're interested at my y midpoint. And this is their question. Velocity initial, once again, breaking this down, it's going to be 2.2 sine of 21, right? It's the opposite angle. So 2.2 sine of 21. And what v final or v midpoint, velocity midpoint, what is the midpoint here at the highest point? This is another key. It's going to be 0. Why is it 0? Because it's a point where the flea is going to turn direction. Before it was moving up, now at that highest peak, it's going to turn down, right? It's going to move downward. So whenever there's a change in direction, the velocity at that moment is going to be 0. Okay, and GA is gravity, right? 9.81. And T, so T isn't going to be 0.16, right? 0.16 is the whole thing, but we're interested in the midpoint, so we have to divide that into 2, which is 0.08. Okay, so let's see how many, what do you call it? How many knowns do we have? We have time, we have acceleration, we have velocity midpoint or velocity final, what do you want to call it, and velocity inertial. So you have 4, that's a lot, right? You have 4, which means you could use any formula, to be honest. So we're solving for, so let's use the equation that has y in it, since we could use any of them. And since we've been using the x change in the x, we could use that one. Or we could use the other one. Should we use the other one or should we use this one? Let's just use this one. No, actually, let's use the other one. It's V final plus V initial times T. Is this the right formula? I'm trying to go off my memory.
I think it's 1/2 V final, V initial plus V final times T.
1/2?
Just one, yeah.
I just need 1/2. Okay. So change in Y, 1/2. My V final or V midpoint is going to be 0 plus 2.2. V initial is sine of 21, and then T is going to be 0.08. Can somebody plug that into their calculator once again? Anybody, please?
I got 0.032.
Is that the answer?
I don't think it is.
0. 0 point what?
0.032.
32. And that is that the answer?
When I checked in the book, it says it was, well, it was in centimeters, so it was 3.2 centimeters.
Yes, so it's going to be the same. So the answer is both, right? The X, which is 0.33 meters. Oops, what did I do? Oh, here it is. And then this one, Y equals 0.032 meters, or you could call it 32 centimeters. Yay.
Guys, I have a question.
And who's this, Daniela? Yes.
Sorry. So my question is, so for this one, since it's velocity of the midpoint,
Mm-hmm.
is it possible to use the other formula for change of y?
Which one?
Velocity initial times time plus 1/2.
Yeah, you could use.
You can use that one?
Yeah, you could use that one. Should we try that one and see if we get the same one? Yeah, you should be able to use the other one, like this one, you mean? Velocity,
Yeah.
velocity y, a change in y equals velocity initial time plus 1/2 AT squared. That one, Daniela?
Yeah.
Yeah, I think you should get the same answer. So V initial is 2.2 sine of T. T is 0.08 plus 1/2. A is going to be negative 9.8. And you're going to square 0.08 square. And I don't know, can somebody plug that in? And to verify it, you get 0.032.
I was just asking because like I don't know for everybody, but like for me, my brain gets confused because like, 3 formulas. But when I can use only one, I try to use one.
Yeah. Did anybody verify that?
Yeah, I did the same formula and I did the one formula and I got it right as well.
Yeah, so you still got this, right? So you should still get the same formula, same answer, I'm hoping. So they should be the same. no matter what equation you use. Good questions. Okay, can I move on to the next one?
Wait, so usually in general, when you're looking for the y final or like y midpoint, when it's like a triangle like that, then you're just gonna do half of the time?
Yes. If it's released from the, like, if it's a parabola, right? If it's a parabola, and because sometimes it's not a parabola, sometimes it's like a half parabola or mid parabola, but if it's a perfect parabola like this, then yes, it's going to be half of time.
All right, thank you.
Any other questions? Okay, I'm going to clear this, clear my